Hello everyone, this is my next video lecture regarding class 11, some basic concepts of chemistry. In this lecture, we will cover the leftover laws of chemical combinations. As we know that there are 5 laws of chemical combination, we discussed these 3 laws in the last lecture. Now, using this law of multiple proportion, I will give you one question. Try to do it by yourself and let me know the answer in the comment section. That try this by using the multiple proportion. The two questions are there. For carbon and oxygen, the oxides are carbon monoxide and carbon dioxide. And for sulfur and oxygen, the oxides are SO2 and SO3. Try to check the multiple proportion and let me know in the comment section. Now, this is the fourth law of reciprocal proportion. In this law, we will discuss the relationship between the masses of the elements when more than two such elements combine between themselves. So we can say that the ratio in which two elements combine separately with the fixed weight of the third element is either the same or is a simple whole number multiple of the ratio in which these elements combine with each other. So we can say that the law of reciprocal proportions was given by Richter in 1792. It states that if two different elements combine separately with the same weight of the third element, then the ratio of the masses in which they do so are either the same or a simple multiple of the mass ratio in which they combine. This is the illustration of the law of reciprocal proportion. For example, consider three elements hydrogen, oxygen and carbon. Let hydrogen, oxygen combine separately with carbon to form methane, carbon dioxide respectively. At the same time, let hydrogen and oxygen also combine with each other to form water. The combination in the element is shown in the form of a triangle where the three vertices of a triangle are carbon, oxygen and hydrogen. By the formation of or a mixing of carbon with hydrogen, we get methane, CH4. With carbon and oxygen, we have CO2, carbon dioxide, and with hydrogen and oxygen we have H2O, that is water. So now let us keep one part of carbon as a fixed weight. So if we fix carbon, so we will consider two cases again, that is one for methane, other one is for CO2. So in methane CH4, we know that 12 parts of weight means atomic mass of carbon is 12. So 12 parts of weight of carbon have combined with hydrogen 4 parts because there are 4 hydrogens. Therefore, 1 part of weight of carbon has combined with 4 upon 12 parts. Similarly, in carbon dioxide, 12 parts of weight have combined with oxygen of 32 parts because one oxygen having atomic mass 16, and when we have O2, it means it will be 32 parts. So therefore 1 part by weight of carbon has combined with oxygen 32 by 12 parts. Therefore the ratio of weights of combining oxygen with the fixed weight of carbon in the two compounds, or the ratio of the carbon combining with hydrogen and oxygen in two compounds, will be given as 4 by 12 or 32 by 12 other ratio. When we have a ratio of them, then we can get easily 1 upon 8 by simple calculation. This goes upside, this goes downside, and during this multiplication 3 cancel with 3 and we have 1:8. The third ratio which we have to compare with it, this is your first ratio equation, and the third is H2O. In H2O, 2 parts of hydrogen have combined with 16 parts of oxygen. 2 hydrogen and oxygen combines in a ratio 2:16 and it will simplify into 1:8. Therefore, we can say that equation 1 and equation 2 both are 1 by 8, 1 by 8. So we can say that both are equal, therefore this law is illustrated. So simply what we have to do, we have to fix one thing and compare to have a ratio of that, and that ratio if equals to the third one or the ratio of the third elements, masses of the elements, then the law is applicable. So I will give you this question. Try to do yourself by fixing with hydrogen as a first case and oxygen as a case. And if you do the same thing, what you will get, think of it. So this is the one case when you fix hydrogen. So you have to firstly compare between CH4 and H2O. On comparing these both, CH4 and H2O, methane and water, in CH4 we have a 4 hydrogen with 12 parts of carbon and 1 hydrogen with 12 by 4 parts of, and similarly in H2O 2 parts of hydrogen with 16 oxygen and a 1 hydrogen with 16 by 2 oxygen. Therefore it will be 8. So ratio will be 3 by 8 and the left one is CO2 Here the ratio of carbon and oxygen will be 3 by 8, as we know that the ratio of carbon dioxide is 3 by 8. So both the ratios are equal of equation this 1 and equation 2. Therefore we can say the law of reciprocal proportion is illustrated also. And the third case, where oxygen is fixed, in that case we have to compare, or we have to get ratio of H2O and CO2 again, and the ratio, we have to get a ratio of CO2 and H2O and compare that ratio with the leftover CH4, and you will get both equations or both ratios are again equal, which also justifies the law of reciprocal proportion. So it totally depends upon you that which element you want to fix. You can either fix carbon, hydrogen and oxygen, but this law is applicable until and unless you are doing the right calculation. So this is a numerical based on this law. We have PCl3 contains 22.57% of phosphorus, PH3 contains 91.18% of phosphorus, HCl contains 97.23% of chlorine. Show that data is according to the law of reciprocal proportion. So for that we know we have a 3 element phosphorus, hydrogen and chlorine. We will get a triangle. This triangle is required if you are doing a reciprocal law. So keep this thing in your mind that always make this triangle before going to write, explain or do a numerical of this law, particular this law. So as we know, we have two phosphorus in two compounds PCl3 and PH3. So we will fix 1 gram of phosphorus as a fixed weight. Therefore in PCl3 weight of phosphorus is 22.57 gram and weight of chlorine will be 100 minus 22.57, as we know that everything is always 100%. So we will replace percentage with gram. So we get weight of chlorine is 77.43 grams. So if 22.57 gram of phosphorus is combined with chlorine 77.43, then 1 gram of phosphorus is combined with 77.43 divided by 22.57. So it will be 3.43 grams. Similarly in PH3, weight of phosphorus is given 91.18 gram. In the weight of hydrogen we can get 8.82 grams. So we can say 91.18 gram of phosphorus combined with 8.82 gram and 1 gram of phosphorus combined with 8.82 divided by 91.18 grams. So we get 0.097. So the ratio of both PH3 and PCl3 will be 3.43 ratio 0.097. So the left third one is HCl. For HCl weight of chlorine is 97.23 gram given and the weight of hydrogen can be calculated as 2.77 grams. So the ratio of chlorine and HCl have combined in 97.23 gram, ratio 2.77. So from equation 1 and equation 2 we can compare both ratios and we get 1:1. Therefore this is the law of reciprocal proportion because both the ratios are similar. One is similar with 1 and 35.37 is similar to 35.10, as both are by round off we get the same data. So now the second question is H2S contains 94.11% of sulfur, SO2 contains 50% of oxygen and H2O contains 11.11% of hydrogen. Show that the results are in agreement with the law of reciprocal proportion. So in this case we know that how to do the things. The simple calculation is that we have a triangle with the sulfur, hydrogen and oxygen. Between sulfur and hydrogen we will have H2S. Between sulfur and oxygen we have SO2. Between hydrogen and oxygen we have a H2O. So we will fix the 1 gram of sulfur as a fixed weight. So we will compare H2S and SO2 firstly. So weight of sulfur is 94.11 gram given. So weight of hydrogen can be 5.89. So 94.11 gram of sulfur have combined with 5.89 gram of hydrogen. So 1 gram of sulfur have combined with 5.89 divided by 94.11 gram. Therefore, we get 0.0625. In SO2, we have 50 gram of sulfur. Therefore, leftover 50 gram will be your oxygen. So, 1 gram of sulfur combined with 50 by 50, that will be 1. Therefore, the ratio will be 0.0625 ratio 1. So, the leftover H2O. In H2O, the weight of hydrogen is 11.11 gram and the weight of oxygen is 88.89 gram. Thus, the ratio of hydrogen and oxygen by combining, we get 11.11 ratio 88.89. Therefore, 0.1249. So, by the simple calculation, we can say that 0.025 ratio 0.1249, we get 1:2. So these ratios are in the simple whole number multiple of each other. So the law of reciprocal proportion is illustrated. Now moving to the fifth law, Gay-Lussac's law of combining volume. In this law, simply the Gay-Lussac gave this law on the observation in which he considered the volume. So this law states that when gases are combined in a chemical reaction, they do so in a simple ratio by volume. Given that all the gases are at the same temperature and pressure, this law can be considered as another form of a law of definite proportion. The only difference between the both laws is that in this law he considered the volume and in definite proportion he considered the mass. So in short, we can say that according to this law, under similar conditions of temperature and pressure, whenever gases combine, they do so in a simple volume which bears simple whole number ratio with each other and also with the gaseous product. For example, first example is the combination of hydrogen and chlorine. The reaction is carried out in the presence of sunlight and HCl gas is formed. H2 is a molecule of hydrogen gas plus Cl2, a molecule of chlorine gas. When 1 volume of each combined in the presence of sunlight, the HCl formation will take place and 2 volume of HCl gas is produced. So we can check the ratio 1:1:2. So all the ratios are a simple whole number ratio. So we can say that volumes combine in a simple whole number ratio according to Gay-Lussac's law of combining volume. Similarly, in second example, the combination between nitrogen and hydrogen, nitrogen molecule in the form of gas, 1 volume combined with 3 molecule of hydrogen gas to form the ammonia, which is also in a gaseous state. So 1 volume of nitrogen, 3 volume of hydrogen will combine to form 2 volume of ammonia. So this is again a simple whole number ratio, 1:3:2. So the question is now, two substances X and Y are colorless gases and are formed by the combination of sulfur and oxygen. Substance X is formed by the combination of 6 gram of sulfur with 6 gram of oxygen. Substance Y is formed when 8.6 gram of sulfur and 12.9 gram of oxygen combined. So the question is, what is the mass ratio of the element in two substances? So we will do one by one question. In first case, in the substance X, mass of ratio of sulfur and oxygen is 6:6, so 1:1. In substance Y, the ratio is 8.6:12.9. So it will be 1:3/2 or 2:3. The next is, which law of chemical combination does it support? So this question makes you to think which law, because this numerical is based on the 5 laws. So just think over it. It cannot be first law because in first law the conservation of mass is there. But here the conservation of mass is not considered yet. So in second law, definite proportion, here proportion is not considered again. So first two laws negligible. Now the moving to the fifth law, volume, here the volume is also not there. So this law also get negligible. Then the law of reciprocal proportion, if we consider that, then in that law we have 3 elements, but here we have 2 elements in 2 different cases. So we left with the third law, that is law of multiple proportion. So this numerical is based on the law of multiple proportion. So in this way you can check the numerical if they are asking you that which law of chemical combination does it support. So third is give the statement of the law, and in that place you can write the definition of the law of multiple proportion easily. So these are the persons behind these 5 laws. This is pic of Antony Lavoisier, who gave us the law of conservation of mass, and this is a pic of a person, Prost Joseph Lois, who gave us a law of definite proportion. Now the thing is, why you are seeing these pictures? Because if you are preparing or if during your education activities with your curriculum, you always go for extracurricular activities which are required. Even one activity is quiz competition. In quiz competitions, you might be getting a picture of the scientist and to check and give the name of the person. So if you have the pictures of the scientist in your mind, then only you will get the name of them. So this is the third scientist, John Dalton, who gave us law of multiple proportion in 1804. This is a pic of Richard, who gave us a law of reciprocal proportion, and this is the last law, Gay-Lussac's law of combining volumes. So Joseph Louis Gay-Lussac in 1808 gave us a law of combining volumes. So moving to next topic, postulates of Dalton's atomic theory. Dalton gave us 7 postulates. You might have studied 5 to 6 postulates in your lower classes, that is in 10th class. Now we are having the 7 postulates. According to Dalton atomic theory, first postulate is matter is made up of extremely small particles called atoms. So we know that matter is made up of atoms, as we discussed in the matter section also, that matter is made up of atoms. So first postulate remains same. The second postulate is atoms of the same element are identical in all respects, that is in shape, size, mass, and also in properties. Here what the same element means, for example, we are discussing atom of hydrogen element. So if we have a 2 atom of hydrogen, both atoms are of the same element hydrogen, both atoms of the same element, that means both atoms of hydrogen will be having a same shape, same size, same mass, and all other properties are totally entirely similar. And According to third postulate, atoms of different elements are differ in all respect. They have different properties also. For example, if we compare again atom of hydrogen and atom of carbon. Atom of hydrogen is from element hydrogen and atom of carbon is from element of carbon. So both the elements are different. So their all properties are also different. This is what said by Dalton, that if atoms of same element are there, they have a same property. But if atoms of different element are there, then they are having a different properties. This scenario is similar with the situation you can see in your home. If two children are from a same family, then they might be having a same properties or identical features somehow. But if two persons or two children are of different families, then they don't have same properties or same features. This is what Dalton said. So the fourth postulate is atom in the smallest portion of a matter can take part in chemical combination. So Dalton said that matter always take part in a chemical reaction but in the form of atoms. The fifth postulate is atom of the same or different elements combined together to form the compound atom, what we studied in a compound also, that atoms of same element or atoms of different element combine to form the compound molecule. For example, hydrogen combine to form H2 molecule and hydrogen and carbon combine to form CH4 methane. So this is for the different element combination in the formation of a compound, and here we will get a combination by the same element. Sixth postulate is when atoms combine with one another to form compound atom or molecule, they do so in a simple whole number ratio, and this we studied in all the five laws, that always atom combine in a simple whole number ratio. And the last but not the least postulate is atoms can neither be created nor be destroyed in a physical change or a chemical reaction. This is what the law of conservation of mass is. So these are the 7 postulates and you have to write all the 7. Anyone ask you a question that what are the postulates of Dalton atomic theory? So what is the explanation of the laws of chemical combination by Dalton's atomic theory? Dalton simply explained or verified the laws of chemical combination by comparing with its postulates. So the first law of conservation of mass, according to postulate 1, matter is made up of extremely small particles called atoms. These can neither be created nor be destroyed in a physical change or a chemical reaction, according to postulate 7. So according to postulate 1 and postulate 7 of a Dalton, he verified that there is no change in mass in a physical change or in a chemical reaction in which atoms of different substances participate. Moreover, in a chemical reaction, the reacting species simply exchange partners to form product. This we have studied in law of conservation of mass also. So this means that there is no net change in the species, atoms, molecules or ions in any chemical reaction. Therefore, the first law of conservation of mass is explained by Dalton. Now, the second law of definite proportion. According to postulate second, atoms of same element are identical in all respects, that is in shape, size, mass and other properties. So when atoms belonging to different element participate in a compound, they do not undergo any change in mass, therefore their proportion or ratio remains the same whatever be the mode of the formation of the compound. This is illustrated with the help of example we also discussed in the law of definite proportion or constant composition, that the source or mode of water can be anywhere, either from a pond, river, lake, tap water, but the ratio will remain 1:8 for a water. So this is the law of definite proportion, which is verified or explained by Dalton by its postulate second. So the third law, the law of multiple proportion, according to postulate 6, when atoms combine with one another to form molecules, they do so in a simple whole number ratio. We all know this means that the ratio by weight of atoms of an element which combine with the fixed weight of the atom of other element in a different compound is expected to remain in the simple whole number ratio. So this justifies or illustrates the law of multiple proportion. Or the second last is your law of reciprocal proportion. So as the atoms combine in a simple whole number ratios to form molecules, the postulate 6 is used by the Dalton. These ratios are bound to remain either same or a simple whole number in compounds in which atoms of different elements participate. So this illustrates the law of reciprocal proportion, and the last law is combining volumes, Gay-Lussac's law of combining volumes, since Dalton's atomic theory does not take account in any volume of the combining substances, he considered the atoms or molecules in the mass. So, he offers no explanation to this law. Therefore, this law cannot be verified by the Dalton. So, the rest of the thing will be discussed by me in the next lecture with you. Till then, thank you.